Hello, this is Mrs. Schroeder. We are going to talk about concentration and solubility in section 13 of our chemistry book today. We talked about solubility a little bit yesterday, and you know that gases can actually dissolve in liquids. We have solute-solute combinations of like carbon dioxide and pop, where carbon dioxide is your solute, pop, the water in the pop is the solvent. We have oxygen in water. Oxygen is a solute, dissolves in water. Now, gas solubility will depend on the temperature and the pressure at which the gas and the liquid are at. So the question is, why does it depend on the temperature and pressure? Well, this guy called Henry came up with a law that says if you have more pressure, essentially you've increased the pressure here of this container. You push that pressure down, so you're at pressure 2. And when you see what happens is these gas particles get squished closer together. When they are closer together, there tends to be more contact, more times that they hit the surface, which means more of them are going to go into the liquid, because when they try to come out of the liquid, they don't have enough space to spread out. So more of them will become liquid. It's basically closer to their vapor pressure. You've changed the vapor pressure, so you've changed how many gas particles can be out. So here's the two rules. If at a higher pressure, more gas will dissolve. At a lower pressure, less gas dissolves. It's able to come out of solution. Again, we've already learned about vapor pressure and boiling point. At a lower boiling point, or lower pressure, we have a lower boiling point. The particles can come out of solution quicker. Same thing happens with solubility. With gases, though, as the temperature increases, the solubility of a gas decreases, which seems kind of backwards from what we are accustomed to with solids. But at a higher pressure or higher temperature, the particles have more speed. And if they have more speed, they're able to escape. And if they can escape, they're not dissolved anymore. So higher temperature means higher speed. Higher speed means able to escape this association with the solvent, and escape from the solution. And if you think about pop, if you open up a pop that's warm, it goes flat very, very fast. It fizzes, lots of carbon dioxide comes out of the pop very quickly, and if you try to cap it up even and put it in the refrigerator, it tastes flat the next day because all the carbon dioxide came out of the solution. Or if it's cold and it stays cold and you put it over ice right away, it stays cold, it tends to be not as flat. Now when we talk about solids, we can actually quantify. We're going to actually quantify how much solute is dissolving in the solvent by using a formula right here: grams of solute over 100 grams of solvent. This is how we talk about solubility. They've used the 100 grams of solvent as an easy way to standardize how much can dissolve in each one. The maximum that can dissolve is called the solubility. And if we look at this chart, this is the mass of the solute added to the mass of the solution, which dissolves. So if I add 20 grams, and right here this is per 100 grams of water, if I add 20 grams, it's going to dissolve. If I add 40 grams, it's going to dissolve. When I get up to 46, this is the solubility. 46.4 grams per 100 gram of water. If I add 47 grams, it's not going to dissolve. If I add 48 grams, it's not going to dissolve. If I add 60 grams, it's not going to dissolve. This is the maximum amount that can dissolve in the water, which means it's called, this term, saturated. Saturated is the most that it can dissolve. And you can see this by seeing the solid particles at the bottom. Then you know you have a saturated solution. So enough solute has been added to reach solubility. It is now called saturated. No matter how much I add, it will not dissolve anymore. Now when we have these charts, it's very convenient for us to use these kind of charts to compare different materials. And we can look at all these different materials on here, and they all have different solubilities. Potassium nitrate has the highest solubility at a hot temperature. the lower temperatures, the sodium nitrate has a higher solubility. So we can use this chart to figure out what kind of solution we have, or what the saturation point would be for any solution we have. In this case, we have 50 grams, and I'm looking for the sodium nitrate dissolved in 100 grams of water, and my temperature is 60 degrees. So I'm looking right here at 60, and I want to find the sodium nitrate line, and I have 50 over 100. And I find this is my 100 grams, so my 50 would be right here. If I do this and I put my dot right there, now what kind of solution do I have? If I wanted to add 60, it would dissolve. If I added 70, it would dissolve. I'm below the saturation, so if I'm below the saturation point, I'm going to have a saturated or an unsaturated solution. So at this point, I have an unsaturated solution because I am below the saturation point. If I go to the next problem, I have 50 grams, but now I'm looking at my sodium chloride down here, added to 100 grams at 60 degrees again. So here's my 60, here's my 50 line, 50 grams per 100, but I'm looking for the sodium chloride, which is going to be right about there, below my 50. So if I'm below the 50, again, I'm going to be unsaturated. So this is an unsaturated solution because I could add more and still dissolve. Next example. In this case, I have 60 grams of sodium nitrate dissolved in 50 grams of water. Now this is where it gets tricky, because I had 60 grams and I only had 50 grams of water. So if I want to figure out this per 100 grams, now notice my chart here is per 100 grams, so I can't just look over here and say there's 60, because that's not equal. What I'm going to do is I'm going to set a proportion up where this is x. You want to solve for x. 60 over 50 is equal to x over 100. X is going to equal 120. You can cross multiply, you can look at proportions. I look at it and say this one times 2. 50 times 2 is 100, so 60 times 2 is 120. X is 120. So really I need to look at 120 on this scale. At 120, and I'm looking for my sodium nitrate at 60 degrees. 60 degrees sodium nitrate is right there. And my 120 is just below it. So if I have 120 grams, this solution is going to be saturated. I can add that to it, but it won't all dissolve. It's going to be a saturated solution. Okay, because I'm actually a little above the line. Actually, yeah, I'm a little above that line there. So, what we learned today is solubility of gases depends on temperature and pressure, and solubility of solids can be measured as grams of solute over 100 grams of solvent, and we're going to use our solubility charts for different materials, temperature and solubility. We can figure out what kind of solution we have. We'll be doing some practice problems in class to work out with these.